Good. All right, beautiful, good. So after doing that, we get this here. Now notice both groups have a common factor of x plus 2. That's good. We want a common factor because that's what we're going to factor out next. Okay, so here, right? So I'm just restating what we saw here earlier, right? Okay, and I just replaced it with 2x, x plus 2, plus -1 times x plus 2. Then if we factor out x plus 2, again, before in the past I showed like all the steps, but I think that was causing more confusion, so I just wrote this. We get x plus 2 times 2x plus -1. Right? That's what's left over. You know, if you take the 2x away from here, you just get, excuse me, if you take the x plus 2 away from there, you just get the 2x. Here, if the x plus 2 is gone, you get -1. So that's what we have. Excuse me, which is this here. Now, altogether then, don't forget about the 3x, excuse me, not, wait, yeah, it was 3x, I'm sorry. The 3x from earlier, we get 3x times x plus 2 times 2x minus 1. And now, when you're solving this equation, you set each factor equal to 0 and solve. So 3x you set equal to 0, x plus 2 you set equal to 0, 2x minus 1 you set equal to 0. So from the first one, you get 3x is 0. That's easy. You just divide by 3. You get x has to be 0. So that's one solution. X plus 2, right? You want to set that equal to 0. And then again, you just solve for x. You get x is -2, as I'm doing here. You know, you just subtract 2 from each side. The third factor, 2x minus 1, we set that to be 0. And then again, you solve for x, right? You want to get x all alone. We add 1 to both sides. We add 1. You get 2x equals 1. And we get that. So then we divide by 2, both sides by 2. Okay, divide both sides by 2. We get x equals 1/2. So the three solutions are 0, -2, and 1/2. So good. Okay, that's good. Are there any questions on this? Again, so let's say instead you had to solve it using the quadratic formula. Well, again, here you can't use it directly. Now, why is that? Well, because you want to make sure it's of degree 2. But what I did was I factored out the GCF. You know, it's good to do that. And just like before, we get 2x squared plus 3x minus 2, right? Because we have 3x times that. Excuse me. So now we have this to solve, and for this we can use the quadratic formula. Right? Remember, if you have something like this, the quadratic formula looks like this. So we have A here would be just 2, as you can see just by comparing. B would be 3. And C would be -2. Remember, you have to include the negative. And then you just plug it into the formula. You get -3 plus or minus the square root of 3 squared minus 4 times 2 times -2 over 2 times 2. And if you do the work, you get, negative 3 plus or minus the square root of 9 plus 16 over 4, which is negative 3 plus or minus radical 25 over 4, which is this. Right? Square root of 25 is 5. So the two solutions are, well, actually 3, but from the quadratic formula, we get two solutions. We get a half and negative 2, right? Negative 3 plus 5 over 4. Negative 3 minus 5 over 4. And so our three solutions are these three. We have negative 2, a half, but don't forget also we had 3x from beginning, right? Just like before. And so when you get that equal to solving that, you set that equal to 0, and just like before, you get x equal to 0. Just like before, meaning here. All right, that's good. Are there any questions on this? All right, here's another one. So I'm going to solve this using the quadratic formula. I also solve it by factoring, but I don't think we'll get to that. But notice, though, it's not in standard form, meaning you don't have a quadratic equal to 0. Right? In other words, you don't have something like this. And that's what we want. So what can we do? I mean, really, I guess you could subtract 7x squared from both sides. What I did was I subtracted 11x, as you can see, and 6. So I did two steps simultaneously. I subtracted 11x from both sides, and I subtracted 6 from both sides. We get 7x squared minus 11x minus 6 is 0. Now we can use the quadratic formula. With, as you can see, a is 7, b is negative 11, right? And c is negative 6. So by the quadratic formula, we have negative 11, negative b, plus or minus the square root of negative 11 squared, minus 4 times 7 times negative 6 over 2 times 7, right? Once we get these. And then, you just simplify a bit, as you can see. Not too much. Turns out that the discriminant, which again is what's under the radical, is 289, which is a perfect square. And that's nice. You get, namely, this. So we get x equals 11 plus 17 over 14, which is 28 over 14, which is 2. So that's one solution. The other one, instead, you're subtracting. So you get 11 minus 17 over 14, which is negative 6 over 14. And then you could actually reduce that to negative 3 over 7. You don't have to, though. You don't have to. Just fix this. But you can, though. Okay, and of course, we get the same solutions as here. Actually, no, sorry, not that. What am I saying? Wrong problem. All right. Now, I was going to factor this, but we have like less than a minute, so I think I'll stop here. So let me stop the recording.